Hello friends, myself I am Madhavi Devi. So today in this operating system session, we will discuss process, process state, process, control block. These are the different concepts which are required for process scheduling. So in today's session, we will discuss the process, what is meant by process, what are the different states involved in process, and how we will represent that process in operating system, the process control block. These are the topics we will discuss in today's session. So these are the following outcomes we will get after this presentation. So the student able to describe the notion of a process. He able to understand what do you mean by a process, and he able to differentiate between a program and a process, and the student able to understand or describe the various states of the process, and also he able to explain how the process will be represented in a memory. So in previous lectures we have seen studying so many of the operating system basic fundamentals. So how to design, how to implement, and how the operating system structure will be look like. In all those concepts, we have frequently used the term the process, right? So today we will go in detail. What do you mean by a process? What is the difference between a program and a process? How it will be represented? What are the different states a process can be occurred? So a process, suppose if you observe here, we will usually write a C program or Java program or some program by using editors, right? So like this we will write a program with the help of editors. So this is a very simple application, famous application, Hello World, which we will give it for a initial stage of the program. So let us see, once we write this program using editors, then after writing, we will save that program with some extensions. If it is a C program, we will give it up hello.c, because I have given a program name is hello.c. Once we have written up the C program, then we will do the compiling based on the different compilers. We can use a GCC compiler, Turbo C compiler, different compilers. So this program will be converted into that machine level language object code, and once it is compiled, it will be enter into the phase of executable phase. Suppose if this program is compiled with the GCC compiler, then this program will be converted into a.out executable file. So here, once the program is converted into an executable file, then we will say that that process is created. It means that a process is nothing but a program in execution. Right? Because we have written a program with help of editor, and after the program is compiled, then we will get it up some executable file. That executable file we will call it as a process. That moment a process is created. So once this process is created, this process will be stored in a memory. This process will be stored in a memory, right? So this part of this process will be stored in RAM, and it is identified with virtual address space, address map of process. So it is identified with virtual address map. It is nothing but a sequence of contiguous memory locations, addressable memory locations. It is a contiguous addressable memory locations starting from 0 to max size. Starting from 0 to max size. So, when within this virtual address space, each process is associated with the different elements, different information will be associated with the each and every processes that are the text. Text is nothing but a code, whatever code you have written. So that text instructions, the code and the relevant data of a process. So in this process, that local variables, global variables, the functional parameters, and all this information will be stored and associated with each and every process inside your RAM, inside your main memory. So, till now, we have seen that a process is nothing but a program in execution. A program in execution. It means that a process is an active entity. It means that a process is an active entity. So this process execution must progress in sequential fashion. Sequential fashion means that one by one instruction has to be executed. So each and every process, a program is consists of multiple processes, several processes, right? Each and every process has that program counter, stack, data section. Not only that, that heap and the text set of the code set of instructions. So all these information are associated with the each and every process. So let me see what are the multiple information or what is associated with the each and every process. So here the program code called a text section, right? So we already informed a program counter. This information is also associated with the program counter, and somewhere actually while in the execution he required some information has to be stored in registers. So that processor registers. So here each and every process is having associated with the text section, that program code and program counter and stack. Stack consists of what are the information will be stored in the stack. So we will store the local variables, global variables. So while we are writing a program, you may have used of the different kind of the variables which are holding of certain data related to your program, right? So that information will be stored inside the stack. So this data section contains the global variables. And the next, another is heap. So heap, it is a part which is associated with the process and it dynamically allocated during runtime, because the process itself is created at the time of runtime. So the memory will be created at runtime. The dynamic memory allocation. Heap is nothing but dynamic memory allocation. Dynamic is nothing but during runtime the memory will be created. The memory will be created associated with the process. So we have already seen that as simple program, it doesn't helpful. Once the program is in execution, then it will be converted and it will be act as a process, right? So it means program is passive entity. Passive entity means that, so it is inactive. There is no active. So here the process is active. The program becomes process when the program will become the process, when that program will be start going for the execution. Start going for the execution means that that program has to bring from secondary memory to main memory, because it has to load it. It has to be present in your main memory. Then only the program will go in a execution, that we have seen in a previous sessions. So the one more point is here, a program, one single program can have multiple processes. Multiple processes. So these are all processes inside that the sequence, it will be executed in a sequential fashion, right? So multiple users are also executing the same program. When actually the program can have several processes means that multiple users will execute the same program. Then actually it has several processes of the same program, right? So this is the way a process will be represented in memory. So we have already seen that each and every process is associated with the text set of instructions, or in another word, code, data, and heap, and stack information. So these are all the different parts of the information will be associated with each and every process in memory. So now let us see that the basic difference between a program and process, right? So we already have seen with the discussion, a small discussion. So we came to know a program, because we already know we will use very frequently the program words, right? So the program is nothing but a set of instructions which are designed to complete a specific task. To complete a specific task. So here in process, it is an instance of an executing program. Means that a small portion of a program which is in execution, which is in running, that we call it as process. So this program is passive entity. Passive entity. Where it will be stored? It will be stored in secondary memory. Program always will be stored in secondary memory. So when actually program has to be executed, we have to load that file from secondary memory to main memory. So then actually that program will be treated as a process, because it is stored in the execution. So the process is an active entity. It is created during the execution and loaded into main memory. So here the third difference. So it exists at a single place. Program will be exist in a single place and continue to exist until it is deleted. Process will be exist for a limited span of time, because when it is an execution means that the CPU has to be allocated to the process. So it has limited span of the time will be existed, and it gets terminated after the completion of the task. So in another words, program is static entity, process is dynamic entity. So here program is passive entity and program is static entity. Both are having similar meaning. Passive means it is no use. Process means it is in a running. It is in an active mode. So, and program, because it is simply in the secondary memory. It doesn't require any resource requirement. So, it requires only the resource requirement is memory. Because memory, we have already seen that the different resources are memory, I by O. files, all these are different resources. So program requires only the memory space, that resource required. But process, it has high resource requirement. Sometimes it may require input output operations. Sometimes it may require different resources to complete the task, right? It may need like CPU, memory address, IO during its lifetime. So it doesn't have the another main difference. Program doesn't have any control block. Any control block. We will see in the next slides how actually process will be represented, but process requires a process control block. Each and every process is having its own process control block, own process control, but program doesn't have any control block. So it has two logical components. Program has only two logical, code and data. So with respect of process, a process may have, in addition to program, code and data, it also requires additional information for managing and execution. It also requires additional information for management and execution. So the main difference between program and process is program is passive entity, process is active entity, right? So it is static, it is dynamic. That's it. So till now we have studied what do you mean by process, what are all the information associated with each and every process in a memory, right? And we have seen the difference between program and process. Now let me move to the next concept, process state. Process state transition diagram, right? So here we may know a process while in the execution, it may enter into the different states. It will enter into the different states. So briefly, these are the different states. So if you see here, the first state of the process is a new state. So in this new state, here it is not, basically it's not a process, right? A program which is in secondary memory, that which wants to get execution. So that program is in a state of new, because once actually the program is ready to do execution, because it is created when the program is in execution, that then actually process is created, that is in the new state. So a process is said to be in a new state when a program is present in the secondary memory and it initiated for execution. Then that process is in a new state. So okay, the process is initiated, the program is initiated. So then the process will be sit in a ready queue. Here all processes who are ready for execution, it is maintaining this state, is having some queue, it is maintaining ready queue, and all processes who wants to get ready for execution, those processes will be reside in the ready state. So a process moves from a new state to ready state after it is loaded into the main memory. So when the process will be in this state, the process is loaded into main memory and it is ready for execution. In ready state, the process waits for execution. Here what actually process is doing, the process is waits for its execution. It wants to grab the processor, right? In multi-programming environment, multiple or many processes may be present in the ready state. That's why here the ready queue will be maintained. So once actually the processes sit in the ready state, then the scheduler will pick, once actually based on the different scheduling algorithm, scheduler will pick the process from ready state and do scheduling the process to the running state. It means that the process is acquiring the CPU for execution, So here it means a process moves from ready state and it assigns the CPU, and we will also termed as scheduled. A process is scheduled to the CPU for execution. So now a process acquires or CPU assigns to a processor and it is enter into the running state, right? A scheduler picks a process from ready state and assign a CPU to processes and it enters into the running state. So some processes, if it doesn't require any other resources, input output, it will finish the execution and it will go for the completion, and after once it is completed its task, then it will enter into the state terminate. But while in the execution, some processes will require some additional resources. For example, input-output completion or IBO operations, right? So IBO operation means that while actually it may require some data or some information has to read from a file, so it requires IBO, right? So once actually this process, while in the execution, it is requesting for input-output operations. Then that time whether the CPU will be idle, because it has to wait, right? The information has to get from the other resources. So that time that process will be enter into the wait state. Or some other time some other textbooks are using the term blocking. So this process will move out from the execution state to wait state till the IBO request is going to be satisfied. Okay, it able to get complete the IBO request. Once actually this IBO event or IBO operation is completed, then that process will again sit back into the ready queue. Then that process will again sit back into the ready queue state. I am ready. Now again, when the turn will come, the scheduler will come pick the process based on the different scheduling algorithms, right? Here, so most of the operating systems textbooks will give the process state transition diagram with this 5 state. What are the 5 state? New, ready, running, terminate, wait, right? But in our previous sessions, when we have discussed multi-programming concepts or different schedulings, so we are in a multitasking type of systems. There, each and every process will assign some time quantum, right? Once the time quantum expires, because we want to give the feel of always is CPU with me, because multi-process, multi-programming in multitasking environment, what we have seen, the CPU will satisfy user's request, will satisfy the user needs, right? For that, it is assigned certain time quantum, or it is assigning some priority. So here, when the process is in running state, once the time quantum, suppose for example 2 milliseconds or 3 milliseconds, if the time quantum expires, then what will be happen? It will be again go back. That CPU will be taken away by other process. So it has to get interrupt and it has to go back and sit into the ready state. So when the time quantum or priority, high priority job comes, or task or process, here in my all sessions, job, task or process, invariably we will use with the same name. Don't get confused. So when the process time quantum expires or high priority process comes, then that process will move from running state to ready state, right? So this is also possibility of one more transition. Now let me see. When actually here in this diagram I have shown up two more states, suspend ready and suspend wait. So when will these states, actually a process will be enter into these states. So till this, the above 5 states, that process state diagram will be deal with the non-preemption kind of the scheduling. So in earlier session also we have discussed what do you mean by non-preemption, and again I will once explain. The non-preemption is nothing but non-preemptive, means that forcibly you are not supposed to take away the CPU, not allowed to forcibly take away the CPU. Means that only process after completion the CPU can allow to give it to the other process, or if it enters into the wait state, then only the processor will be assigned to other process. That type of mode, that type of scheduling is nothing but non-preemptive scheduling. So in later sessions, we will study of different scheduling algorithms which will come under non-preemptive scheduling and which will come under to the preemptive scheduling. The vice versa, opposite. So preemptive means that I have, suppose some high priority process will come and rise or interrupt. So then I can allow to give the CPU to the high priority process. That scheduling methodology is nothing but preemptive scheduling. So the before all these 5 states, new, ready, running, terminate, wait, this all state we will see with the non-preemptive scheduling algorithms. Along with the non-preemptive scheduling, suppose in preemptive scheduling, at the time of preemption scheduling, or because here there are the chances. So suppose we already know that a memory is limited, right? We can't able to keep all so many of the process inside the ready queue and trying to assign or trying to grab the processor, right? So when high priority process comes, so then we have to take away that when high priority process comes and there is no memory space in the memory, then we have to suspend that process from ready state to suspend ready. another state, right? So here, if you observe, this suspend ready state will be available in secondary memory. The remaining all the state where the process are there, it is in the main memory only, because new, ready, running, so in waiting, these are all actually when the process is in the state, that means that the process is inside the main memory, right? So here, due to a limited memory, sometimes if the ready queue is full and high priority process is trying giving the interrupt, then that process will be suspend from ready state and keep it that into the secondary memory with the state of suspend ready. Okay. With that, what we are trying to give? We are giving some space to the high priority job and sitting in the ready state, in ready queue. Okay, ready queue is acquiring the CPU, then it is completed, it is terminated. So then actually space is available. Once the space is available, that suspend ready process will be go back and sit again in the ready state, right? So here the same process will be happen, because these two states will be arise at the time of preemptive scheduling only. Preemptive scheduling. So suspend ready, suspend ready, and suspend wait. In both these will be happen, or this process will be enter into this state of under preemptive scheduling, and this will be in secondary memory. That time the process will be sit in secondary memory, right? Here at new time, that time also the program is in secondary memory. These are very important questions. Sometimes you may get it in a gate point of view. So here the question will be, suppose if a process is from new to ready, that time where that process will be sitting. That process is in a secondary memory. So here like this, the questions will be come into the very important questions. So we should come to know here, if you observe here, wait state, when actually here also wait queue will be there, when there is no space. So that time it will be enter into the suspended from wait queue and again keep it into the suspend wait. So here a process moves from wait to suspend state if a process with high priority has to be executed in main memory and that main memory is full. That scenario actually it will be enter into the suspend wait. So once actually memory is available, once some space is free in the waiting queue, again that process will be resumed from suspend wait state to again wait state, and then the following consequences or following sequence of the actions will be happen. Once the IBO completion, once the different activities are over, it will be enter into the corresponding states, right? So I hope so. This process state transition diagram, it will be very helpful. You understood. So that only a process is in new state when a program present in secondary memory, it is initiated for execution. So these are all about of the. Now let us we move to the another concept. another topic which is related with the process control block. Process control block. So I already keep on informing, each and every process is represented in operating system by a process control block. Because once actually process is initiated, is created, then so much of information will be associated with the each and every process, right? So what are that information is associated with each and every process? So we already have seen the process states. So what are the process state? New, ready, running, terminated, wait. So these are the different states we have seen. That process state where actually the process is associated. That information will be available inside in the process control block. Program counter, CPU registers, CPU scheduling information, memory management information, accounting information, IBO status information. Not only this, many of the information will be associated with each and every process and represented in the operating system with help of process control block. This is a data structure maintaining such a kind of information. So this is what actually, so the representation of process control block in memory. So process state, process ID, program counter, the number of registers, the general purpose registers, memory limits, list of open files. So now let us see each and every element or attribute. What this attribute, because I am saying PCB is a one kind of is a data structure. It structure is a data structure which is associated with the different attributes, and different attributes are holding different kind of information associated with each and every process. So let us discuss each and every attribute, what information will be hold. So the process ID or program, if you observe the process number. So each and every process is having of their unique process ID. With that ID only, that will be getting allocated by the CPU. So it is unique that identifies each process of the system uniquely. It is, this ID will be assigned during the creation, during its creation. A program counter, what is actually program counter attribute? What it will do? This counter attribute will consist of the address of the next instruction to be execution. This is main important actually. The program counter, with help of program counter only, a process can able to execute in a sequential manner. So a program counter consists of address of the what next instruction has to be executed. So this program counter attribute is having a this information. So now what kind of the priority, that also will be specified with help of priority. How urgency are to execute that process, right? High priority, then the CPU has to be allocated first. While in the execution, so we may use different kind of the or different registers which are able to hold the values which will be required. Values in the sense of that the data associated with the code or associated with the program. So that data will be stored in the registers. For example, accumulators. So you may have studied, if you may have studied of processor AX, BX, ABCD, some 4 registers and accumulator. Accumulator, while doing in the arithmetic logic unit or arithmetic logic operations, that time the temporary values will be stored inside the accumulator for quick further manipulations. So this entire information will be stored in general purpose registers. That attribute will be taken care, and the list of open files. Each process requires some files, because we have seen, right, while in the process in the execution it may require some IBO operations. So for that, which must be present in the main memory during its execution. So the PCB will be maintained. What are the different list of files are associated with this process during the execution. So this will be, these are the different kind of information will be stored in attributes, and that attributes are presented in process control block, and each and every process is represented in the OS with help of process control block. So how this is the diagram. Suppose if you consider there are two processes, P0 and P1, and how actually CPU will be switched from one process to another process, right? So where actually this PCB will be helpful for us. So when actually the process P0 is in execution, it is in execution, then some high priority process comes and it is generating an interrupt or some kind of the system call. It is given by the operating system. Then that time we have to save that state into PCP0, because each and every process, if you observe here, that P0, that sequence number, so that is a 0th process. So has their corresponding process control block. So when actually interrupt or some system call comes while in the execution, that state will be stored inside the PCB0. Then the CPU will be go and attend to the another process, right? So that time, up to that point, till that CPU is going to get to the P1, that time P1 is in an ideal state. So okay, P1 is start executing. Then before the P1 is also is in somewhere in the ideal state, that state will be reloaded, the state from PCB1. So I already have informed PCB contains the process state. So is it in a ready, is it in a running, is it in a wait state? So different state we have seen in the previous diagram, process state diagram, the different states. So a process may be in any one of the state. Once actually CPU is assigned to a process, it is in a execution state or it is in a running state. So if it is in idle, it has to retrieve that saved state from PCB1. Then again, once actually the execution up to that point when actually the process 1 is executing, then up to that point P0 is in a ideal state. So again, it has to be that process 1 is executing. Then once actually is again some interrupt or some system call is coming, then it will also save the state into the PCB1. To better clarity, I will just give a small real life example. So suppose you are studying. So some friend comes. That means that some interrupt is happen for your work. What you will do? Whatever you are doing the activity or studying, you will save that state up to what portion I have studied. Right? You will keep back that state, keep that state in one place, and you will go and meet your friend, and then you do some activity, and then once you come back, you will reload the from past state onwards, from wherever actually you are started. From that portion onwards, you will start continue. The same fashion will be happen. So it means that the switching CPU will be switched from process to process. This is nothing but context switching also. So I hope so you understand what do you mean by process, what are the different states are associated with each and every process, what is meant by process, control, block. So these are the different sites I have referred, the Galvin book and Tannenbaum and Geek for Geeks Get Vijay. Thank you. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.